Hey, I'm Mr. Bahork, and today we are doing equations with two variables. So before, we had equations that were very, very simple. They were just basically like x plus 2 equals 4. There's only one variable in that. And with this kind of equation, there was only one solution. It's 2. It's the only number you can plug in that makes it true. Well, now we're going to look at equations with two variables. So before we want to know what x is, but now we're going to want to know what both of the variables are. So let's take a look at an example. And let's do y equals 2x plus 1. So you'll notice that there are two different variables here. It's kind of hard to solve for one of them since we have two different ones. So there's going to be two numbers in our answer. We want to know what x is and we want to know what y is. Well, this gets kind of interesting. So let's play around for a second and let's just say that x is negative 2. So x, let's say it's negative 2. If we were to plug in negative 2 into this equation right here, I'd get y equals 2 times negative 2. I don't know why I'm writing that up here. Y equals 2 times negative 2 plus 1. Okay, so well, what is that? That's negative 4 plus 1. That's negative 3. So y is negative 3 when I plug in negative 2. And isn't that an ordered pair, x comma y? It sure does sound like one. So it looks like that is a solution because I can plug those numbers back into this equation and it'll be a true statement. A solution is anything you can plug in that makes it true. So, but wait a second. Doesn't that mean I can plug in a lot of different things? So let's take a look. Couldn't I also plug in 0? Okay, so y equals 2 times 0 plus 1. Well, that's just 0 plus 1, so 1. And that's also a solution. I can plug that ordered pair in, and that'll work. Let's plug in another one. How about 1? Y equals 2 times 1 plus 1. Well, that's easy. 2 times 1 is 2, and plus 1 is 3. Sweet. So I plug in 1, and I got 3. Well, if you notice, I can plug that in and get a solution. So I could keep going, couldn't I? I could just pick random x values forever. So there's no way to write out all of these ordered pairs because it would take forever. There's an infinite number of solutions to this equation. So what we do when there's an infinite number of solutions to something is we just graph it. We draw a picture of it so we can represent what it would actually look like. So let's graph these 3 points and let's see what happens. And I'll graph in red. So negative 2, negative 3. So over 2, up, or sorry, down 3. I lost my space. Here we are. Okay. And 0, 1. So that's right here. And 1, 3. So that's right here. Sorry, it's a little bit hard to graph with this tablet. Alright, so I've got 3 points. Now remember, I could pick any values for x, plug them in, and it's a solution. And if you'll notice, these line up very nicely. So I'm going to do my best to draw a line through these on this tablet. I've never really tried this before, so let's take a look. Oh boy. Oh, wait. That's not bad, I guess. That's pretty bad. And I'm going to draw the arrows on the end of my line because this could go on forever. Okay, it definitely could go on forever. So I could take other points. I could say, you know what? Let's take 2 and 2, 5. That's on that line. So I'm taking a point right off of the graph and I'm saying, you know what? Since it's on that line, it has to work in that equation because that line represents the solutions, all the solutions to this equation. So if 2.2 comma 5 is on that line, then I can plug it in and it should work. And let's take a look real quick. 5 was the y value, 2 is the x value. 2 times 2 is 4 plus 1. Then, hey, 5 is 5. It works. If I were to pick a point way out in nowhere's land, like, I don't know, let's say 3, 1. Okay, that means that 1 would be the y value and the x value would be 3. So I'd end up getting like 7. And that's not the same thing as 1. So it doesn't make sense. So it's off of the line. So the line represents all the solutions. That's the answer, is the graph. That graph is your answer. It was pretty awesome. All right, so let's go ahead and erase this up a little bit. Let's see. I'll erase the graph too. Okay, cool. All right, let's go back down. And, okay. Now, going along with this, now let's say I didn't give you one that looked all pretty. I'm going to give you maybe an extra set of directions here. Let's say I give you 3x plus y equals -5. And I'm going to tell you, you know what? Solve for y and then graph it. Whoa, where's... Oh, goodness. So we got to get y by itself. Okay, we got to solve for y. What we want to do when we're doing that is subtract 3x on both sides, which is a very helpful step because then y is by itself. Y equals -5 minus 3x. There's nothing else you can do to that. They're not like terms. Can't combine those guys. Alright, so now we solve for y, and now we got to graph it. Well, to graph it, we're going to need some x values. And it doesn't matter what you pick as your x values. Just pick some numbers to plug in for x, find out what y is for each of those numbers, and you've got a bunch of ordered pairs. And once you have three or four ordered pairs, we can graph it. We connect the dots and we make a line. So this time we want to pick easy numbers to graph though. You have to keep in mind that while we could plug in 592 for x, that would not be the funnest thing to graph. So we're going to want to pick numbers that are good to plug in. So let's plug in some numbers. We'll make a little table of values. That's supposed to be a y. Okay, so let's say x is, I'll start with an easy one, 0. Why not? Okay, so -5 minus 3 times 0. Well, that's just -5. Well, that was helpful. Okay, so how about maybe, let's do -3. So -5 minus 3 times -3. Be careful, remember that's adding the opposite. So it's like saying -3 times -3, which is 9. So it's like saying -5 plus 9, which is 4. Alright, let's do one more point. I just want to make sure that we have enough points to graph something. So how about -1? Okay, when I plug in -1, you should get -2. So we've got 3 points, and we should be able to make a nice pretty line with 3 points. So let's go ahead and do that. So we'll bring up a graph. Alright, now let's move it over. Okay. So we got 0, -5, so that's down 5. So right here. Okay, we got -3, 4, so back 3 and up 4. And we've got -1, 2, so back 1, down 2. And those line up pretty nice, so you know you have the right points here. If your points are all over the place, they're scattered, okay, and that's probably not a good sign, because for most of these, they're called linear equations. That means when we graph them, they're going to make straight lines. As long as x is by itself, and there's nothing crazy being done to x, like there's no x squared or x to the third, it's just a regular x over here, it's going to be linear. We'll talk more about that tomorrow when we do slope and that fun stuff. Alright, so let me draw my straight line, as straight as it can be. That's good. Okay. Draw my arrows on the end because it does go on forever. And that's my answer, is that line right there. That is my answer. So real quick though, I want to show you what happened. What if we had some, I don't know, some crazy equations. Let's make these equations a little bit crazier than normal. And I'm going to need 2 graphs for this. So let me change my brush back down to a small size. Not that small. There we go. Okay. Let's say I've got this graph here, another graph right here. What if I gave you the equation y equals 2? And then over here I said, you know what, x equals 5. What in the world would you do with these? Well, this is kind of something that you should learn. It's really helpful. It's kind of a shortcut once you learn it the first time. Well, when you have y equals 2, that basically means that, well, there's no x. You can kind of say there's an x if you want to. Like, you can say, okay, how about times x to the 0? And x to the 0 is always 1, right? So 2 times 1 is 2. So it doesn't really change anything. So you can plug in values for x all you want, but it's always going to be 1 right here. This is always going to end up being 1, no matter what you try to plug in. Which means that y is going to be 2, no matter what you try to plug in for x. So if I tried to plug in 2, y is 2. If I tried to plug in 4, y is 2. If I tried to plug in -6, y is 2. If I try to plug in -4, y is 2. So I think you kind of see the pattern. Even if I try to plug in 0, it's 2. It's going to be a perfectly horizontal line. Well, I hope that's perfectly horizontal. Kind of tough to do. Alright, so it's a perfectly horizontal line. Whenever you have y equals just some plain number, some constant is what we call that, it's a horizontal line. And by logic, if you have x equals some number, it's going to be a vertical line. And basically what that means is no matter what I try to plug in for my y to the 0 right here, which doesn't really, we don't have to write because it's always 1. Okay, whatever I try to plug in for y, it's always 5 on the x. So if I try to plug in 1, it's going to be 5. If I try to plug in 2, it's 5. If I try to plug in 6, it's 5. If I try to plug in -6, it's still 5. Pretty exciting, I know. So it's going to be a perfectly perfectly vertical line, which means it's most definitely not a function. It fails the vertical line test all sorts of epically. So that is definitely not a function. Alright, and that's about all I'm going to do for today with equations with two variables. I'm trying to do this without mentioning the word slope. This is right before we're doing slope, so I'm trying to mention this without slope. But tomorrow we'll talk about slope, and it'll be lots and lots of fun because slope is super awesome. Alright, I'm Mr. Bajork, and that was equations with two variables.